everyone, and welcome to the last part of Activity 24, Lesson 24.3 on page 345. Today we are going to talk about the tangent theorem. So you're going to want your reading guide with you to finish up the last of Activity 24, a pencil, and a calculator. I'm going to start today talking to you about an ice cream cone. Right? If you have an ice cream cone, you want to make sure that your ice cream stays inside the cone and doesn't become big falling out of your cone goopy mess on the ground. And part of the way you can stabilize that cone is by having a nice cone that is symmetrical on either side. Well, when we think about the tangent theorems, including tangent segments, we want to think about this like our cone here, or our ice cream is a circle, and the pieces of the tangent are the sides of our cone, right? Touching our circle at one spot each. Now, both of these tangents meet at this point outside here at the tip of the cone. Okay, that is going to translate to what we're talking about today because we need these pieces to be congruent to each other if they're tangents coming from the same external point. So we see that here. This is, again, the tangent segments, which we've talked about before. And again, if they're coming from that same point, in this case, point D, outside of the circle, they are going to be, BD is going to be congruent to CD because of this, okay? Now, there is a big theorem that actually goes back to proving these triangles are congruent that we could draw inside here because we know that to the point of tangency we have right angles, and if we draw this in here then these are congruent to each other, and then we know all radii of a circle are congruent to each other. So because these triangles are going to be congruent by hypotenuse leg, which we will see down here, which has been a while since we've talked about that, these that's why we're allowed to say by CPCTC that these two segments are equal. Okay. Now, we are going to use that fact a couple different ways. One of them is what we call walk-around problems. And notice we have a bunch of different segments, tangent segments being given here. We have TH, which we know is congruent to TA. And then we have RH and RD because they're both tangents to the circle from point R. And finally, DM and AM. Okay, would be congruent because again, see, it's like the ice cream cones all the way around. It's like we have three different ones. And if we label our diagram, they're telling us that R to T, this whole segment here, is 12. Then they're telling us R to H inside here is 5. And then M to T is 21. Okay. And we want to figure out what our remaining sides, particularly our M is. Okay. So we know that RH is going to be congruent to RD because of that tangent theorem. So those are both 5. And if our whole segment here is 12 and this little piece is 5, this remaining piece would have to be 7, which also makes TA 7, right? Because together 5 and 7 need to be 12. Well, if this whole thing is 21, then we know 21 minus 7, this piece would have to be 14, which makes DM also 14. So together, the length of RM is 5 plus 14, or 19. Okay. Now, we know also that we can solve inside of this picture. If they ask us to draw in our H, and we have these tangent lines, we know we are creating right angles. So a reminder that fact still holds true that you have right angles at the point of tangency when you're trying to solve pieces here. So we have the right angles occurring to be able to solve for different pieces. Because if we want to find the length of O to T in part B, and they're telling us O to H is 4, well, we know this is 7. And so this right triangle inside here, I'm going to redraw it over here to the left. This we could label, we have 7, we have 4, and now O to T is our hypotenuse, right? So we could use Pythagorean theorem to solve. So don't forget about the old tangent theorems that we talked about in 24.1. Okay. Now, we're going to skip number 3, but if we look at one last example, which is number 4, we're going to see another walk-around problem based on the front page. So on this particular walk-around, they're giving us that R to M is 40, and then they're telling us that AM is 32, which we know is going to be the length of DM as well, since they're equal to each other. Now that's going to help us find R to D, because 40 minus 32 is 8, which is also R to H. But those are the only measurements we can find. Okay, we can't find any others besides the 32, the 8, and the 8, because we don't have enough information to figure out the rest of this. Okay, if we knew the length of TM or TR, we possibly could. All right, one final problem we're going to do together is one like number 5. In this diagram, we have two tangents, which we know are congruent because they're both coming from that same point. And we have a radius being given as 5 centimeters, which we also know we could draw in over here as well. MN, they're telling us, is 12 centimeters. And they want us to figure out two different pieces of information. What is QN? And what is PN, the length from our center to the point outside the circle. Well, we know that QN out here, based on our tangent theorem, has to be the same to keep the equal size ice cream cone, has to also be 12 centimeters, right? And we know in order to solve for PN, we need to look at the fact that this is a right triangle with our right angle coming at that point of tangency M. So we're actually looking for the hypotenuse then when we're looking for PN. So C squared equals 5 squared plus 12 squared. 25 plus 144 is 169. And the square root of 169 is 13. Okay. Thanks for watching and congrats on finishing activity 24.